Okay, so on this one, we've got two triangles, and it says find the unknown lengths. So make it a little bigger here. So you can see that there's an X here and a Y here, which we're trying to find. So, and it says these are similar triangles. What are similar triangles? It means triangles that are basically the same shape. One's just a bigger version. See how these kind of look the same, but this one is bigger, and this is the smaller version, right? That's what similar means. Similar means the two things are the same shape. One's just a blown up version of the other, or the other one's the smaller one's a shrunk down version, however you want to look at it. One's a bigger version, one's a smaller version of the same shape, right? No, it's not like you could have a totally different with that. Like that triangle looks totally different. That's just a completely different shape altogether, not just bigger or smaller. That's just different, right? Whereas these are the same shape. One's just a little bigger, one's a little smaller. So, okay, so what? Well, that means we can take the left over the left equals the right over the right equals the bottom over the bottom. Those, the way we say it is we say the ratios are equal, right? They're all equal. Now that you can take the sides and you're going to get the same ratio. So notice this is the left, bottom, right of the first triangle. And this is the left, bottom, right of the second triangle. So what that means is I can take the left. Let me do it like this. I can take the left over the left, and that's going to equal the bottom over the bottom, right? Left over left, bottom over bottom. Now let's fill in the numbers there. What is this left? 4.5. What is this bottom? 12. And this left is 6.3. And this bottom is y. So I can use that now to solve for y. Let me pause for just a minute. Am I going too fast? You see what I just did there? I went left over left is bottom over bottom. Because that's what it means when you have similar triangles. I should say for similar triangles, the ratios are equal. So you can take the left of one triangle over the left of another, and that's going to equal the bottom over the bottom. So I did left over left equals bottom over bottom. And that's going to allow me now to solve. Now solve for y. How do I solve? Go diagonal. Remember, we've learned when you have just two equal fractions, you can just go diagonal. So 4.5 times y equals, and then 6.3 times 12. Like that. So 4.5 times y equals, and you just use your calculator. I'm gonna grab mine here. 6.3 times 12, whatever that is. I'm getting 75.6. And then last step, to solve for y, divide by 4.5. Boom, boom. Y equals 16.8. So I was able to find y, 16.8. All right, and now we need to solve for x. How are we going to solve for x? Well, x is got the right side. So I'm going to have to go like, so here, let me separate things here. So that was the y. Now I'll go over here and do the x. For the x, I'm going to have to go right over right. Why right? Because that's where the x is. The x is on the right. And then what are you going to put with that? Well, I could do the bottom, but you know what? That's the y. Well, I could. It doesn't matter. You can do bottom with bottom, or you could do left with left. I'm just going to go back and do left with left since both those numbers are just clearly there. I'll do left, but it'll work either way. It doesn't really matter. So I'll go right, right, left, left. You could do bottom, bottom, whatever. It doesn't matter. Any of them will work. So what's the right here? It's 11 over x, the right here, x equals left is 4.5 over, and the left here is 6.3. Like that. And then you know what to do. Same thing, diagonal, diagonal, cross multiply. So 11 times 6.3 is 4.5 times x. And then use your calculator. And I'm getting 69.3. 4.5 times x. And then solve for x. Divide both sides by 4.5. And I'm getting 15.4. And so we got x, 15.4. We already had y. And so there we go. So similar triangles means they're the same shape. One's just a bigger version, the other's a smaller. So in that case, the ratios are equal. The left to the left and the right to the right and the bottom to the bottom are going to be equal ratios. So you can set up any of those. So I did the left, left, bottom, bottom. At first, left with left, bottom to bottom, and that involved y, and I was able to solve for y. And then I went back, so okay, I need x, that's a right. So I did right over right equals left over left, but you could have done bottom over bottom. That would have worked just as well. Cross multiply, that involved x, cross multiply, solve for x. And there we go. We can find the missing sides of the triangle just by knowing that these two triangles are really the same shape. One's just a bigger version, the other's a smaller. We're able to find the missing sides. People use this all the time in the real world to figure out parts of shapes that are similar. And so there we go.